Lesson 9 is on ionic compounds. If you'll remember, ionic compounds don't exist as molecules, they exist as crystal structures where positive and negative ions alternate and are attracted to each other. So we have these larger crystals. A reminder about the types of bonds. Ionic bonds involve electrons being transferred and therefore forming ions. Covalent bonds, which we've seen a lot of, electrons are shared. Just a reminder of something we did earlier in the class, we can predict the charge of an ion based on an atom's or an element's location on the periodic table. In this first column, they tend to form +1 ions. Second column, they tend to form +2. This is our +3 column. Noble gases don't tend to form ions, but next door these form -1, the halogens. These are -2, and these are -3. Now we're ready to look at some Lewis dot structures. The goal, again, is to get an octet of electrons. And so we see chlorine is just one short, and sodium has just one valence electron. So what will happen, of course, is that there will be a transfer. This is a metal and a nonmetal, so we'll get an ionic bond forming. When that occurs, sodium now appears to have no valence electrons, and so I will give it a positive charge over the whole thing because it's lost a negative electron. And now chlorine has 8 valence electrons, so it's stable. And it has a -1 charge because now it has an extra electron. Remember the words anion and cation. Anion is for the negative ion, the chloride here, and cation is for the positive ion. You can remember because the T kind of looks like a plus sign. What holds these two together is an electrostatic attraction. They're not sharing electrons, their electron clouds are separate. But one's positive and one's negative, so they do attract. Now, we said that chlorine has an octet here, but so does sodium. We are just not showing it. Let's look back at our periodic table. Sodium is right here. So if we remember how this works with our periodic table and electron configurations, sodium has 1 electron in the 3s energy level. If it loses that 1 electron, then it has the second energy level already full with 8. So when sodium loses that 1 valence electron, it is now stable, it has its octet. We just don't usually show those once they're gone. Let's draw another Lewis dot structure. This time let's do calcium bromide. And we'll just start with the calcium. Calcium on the periodic table has 2 valence electrons, and bromine is a halogen, it has 7. So what's going to happen is that one of these electrons is going to go over to the bromide or bromine to make it bromide, so it'll have its octet. But we have another electron here, and calcium needs to get rid of that one as well to have its octet. So we need to bring in another bromine atom. And then we can have another transfer take place. So in other words, we'll end up like this. So that now we have a neutral compound and all of the electrons went somewhere. We can never just lose electrons. They have to go somewhere. You can't have any left over. And this is what we did before when we would say that calcium normally formed a +2 and bromine normally forms a -1, and we cross these down. We got the same formula that way without considering all the electrons.